Nigel.
Oh, hello. And if I'd known that, I could have put some Woking SC slides in, couldn't I? Just to cheer everything up. So I have modified the standard template for Network Rail for those for the avoidance of doubt. And I did at one point have a whole series of all the ones down the side and bottom being with a rail on as well. But you'll be pleased to know that was the case today. So the title was alluding to, what the heck do I talk about to such a great group of people here today? So I said life, the universe and everything, which if some people will recognise that from a great radio and TV and book by Douglas Adams, Hitchhiker's Guide to the Galaxy. But that's it. There will be no other references. You'll be pleased to know. Oh, shit. Apologies for those that don't know about Hitchhiker's Guide to the Galaxy, but if you haven't, it's you can actually watch a little bit on Catch Up and on YouTube, and you can buy all the CDs or DVDs, and it's absolutely fantastic. One thing I warn about is that I'm likely to start standing up and waving my hands around a lot. So those that are on Teams, apologies if I suddenly disappear and you just see either my trousers or my belt or anything else. I will try, and my colleague Mr. Meads here will try and keep me honest and adjust as necessary throughout the throughout what we're doing here. So I'm going to start off with standing up. About a little bit about myself and engineering, and I think one of the things that I want to talk about today is I've been so lucky in my career by working in lots of different parts of the business and lots of different experiences. And I've then got some other slides to talk about the system and why I think that is so important. And then I'll go into a little bit more now about developing the vision about what we want to do EMP in southern region. And then got a little bit more detail behind about our safer, smarter isolation, decarbonisation, a little bit about, what we want to do to try and generate our own power, and also about things like future infill DC electrification. So if I get stuck, Mr. Major, also kick me if I waffle for too long. So let's make a start. So. For myself, I started off in BR days. I'm in my 38th year in the railway. And I started off, interestingly, doing some OLE design and OLE distribution design around the Ipswich. It was at the time the Colchester-Norwich electrification was underway. And actually, one of my tasks, and this was a great piece of integrated thinking. I lived in Bury St Edmunds, which was actually not too far from Ipswich. Other than Woking, I'm an Ipswich Town supporter. And actually, what's better than do a site visit on a Friday when you can then go and watch the game on the Saturday? So I still have some structures in Ipswich Yard. They were all hand designed, all bespoke type of bits and pieces, and did play with the computer-aided design on plane line for a little bit. So sometimes people think I'm only Conrail. That's not totally true. I did do some design and actually testing on things like East Coast Main Line electrification in the 90s. I then somehow managed to find myself on a development course, this is what I call it, which meant I went into rolling stock for a while. So I went to Doncaster Works, York Works, a little bit in York, in Hudson House and York, and then to the tech centre. And whilst, apologies for not clicking necessarily. So thinking that the system should be, artificial intelligence should know exactly when I need to click forward. There we go. So that was a period of time where it really was predominantly looking at rolling stock at Doncaster. And for those that like looking at pictures of trains, I actually added things so that, because I know some of you like looking at pictures of old trains. So that's a Class 31. And I was at Doncaster where they had their sort of last real heavy general overhaul, which was a complete power unit refurbishment, all the body sides replated. and basically kept them going for another 10 to 14 years. And actually, in all of this, and this is where there are loads of analogies, you learn loads and loads and loads in that sort of environment from people, not because I ever wanted to be a rolling stock person, but I'll give you one example. So one day, one of these things came into the works, been out because they were so reliable, it'd been out for about 8-9 years. Power unit was filthy inside, covered in grease. And we had to get the power unit out. So there was a load of bolts around the side, because it's not a monocoque construction, it's a big underframe type thing. So you could just undo the bolts down the side, and then you'd think the roof would lift off to make it easy to get the power unit out. But in the 50s, when they were designed, they had this lovely design for how the exhaust was connected to the roof, which was at really high level with quite small studs that, of course, because it had been hot, they got seized, right? That you then had to climb up the side of this filthy power unit to get to these studs that are seized, that you couldn't put a ring spanner on because they were a bit too long, the studs, to get a ring spanner on them. So you had to, with an open-ended spanner, try to get these bolts off that didn't want to come. So you end up, it was of all the PPE and all the other stuff, your knuckles and all your everything else went covered, overalls absolutely covered in dirty oil grease. Of course, no one else did it. Everyone else just went and had a cup of tea and left me to do this. And then the team leader, the foreman in the shop, turned around and said, "Right, lad," he said, "what have you learned from that?" And I said, if ever I get a chance, I'm not going to design something so bloody stupid where it's so easy and then you get something that takes 2 or 3 hours to actually sort out. And that's the sort of thing that, going into those other areas, you've really, I benefited from picking up. I'm going to be working on my career on working on locos, but that was something that, for example, when I went into maintenance, that always sticks with me. So if I'm in projects, I'm in maintenance, I'm always looking, how do we maintain it? There's always more than one way of engineering a job. There's an easy way for maintenance, and there's a way that can be a right bugger. And I always try and think, right, 5, 10, 20 years time, what are we going to be doing to this to try and make it, to try and learn the lesson, if you like, of that design that was brilliant, and there's still 1 or 2 of them floating around there that good, other than they slight design deficiencies in one particular area. And then class 58. So I was lucky. In Doncaster, they were building new locos at the time, and at the time it's class 58. So that's the other thing, you're getting old, is when things like class 58 are deemed as being life expired. And you think, oh my God, it wasn't that long ago that I was in Doncaster Works building them. And there are 1 or 2 cabs that have got my fantastic wiring in them, hopefully still. But again, lots of lessons learning about the whole concept of the 58 was really, really excellent, let down by 1 or 2 basic fundamental faults, such as it didn't have a very good adhesion system. So it used to slip a lot and couldn't actually do what, for example, a class 66 does, or a class 60. It didn't have that level of intelligent control to be able to have that creep because any slip you have, slip's fine. It's when you get uncontrolled slip and it breaks away is the problem. And actually managing that level of slip is what modern systems do. Unfortunately, the 58 didn't have it. It had a very crude slip control system. When it spun, went out of control, and then the whole bogey was lost in terms of power, which is why, on a dry day, no leaves, they were fine. But in a colliery with wet slurry everywhere, or in autumn, they were a bit difficult. And then there were things like class 319s, 319s, again, coming near the end of their operational life. Did some work about interface between power and signaling. I actually wrote a computer program to do some simulations of what happened when the control software went into various iterations of a loop to prove you could get 50 hertz on the power supply, which clearly could upset 50 hertz track circuits. which then went on to do testing, and that's where we got the specs effectively from today, and the ICMUs and all of that type of, which is interference current monitoring units that we have on today's trains, and even Class 91s. I did some work on, and then probably Jack will start smiling now. Came to Southern, started to look at things in the services section. East Grinstead line, commissioning test, Bournemouth Weymouth system design. That was the part of, if you like, looking at the system from the electrification point of view, testing, short circuit testing, doing some wonderful tests at Wimbledon. So we used to have a setup at Wimbledon, high current test facility. Today, we would just not put one of our key, in Wessex, one of our key routes at risk by doing short circuit tests. BR days, it was right by a grid, highest fault level, 3 rectifiers, jobs are good. And, you know, you give some equipment a really hard test in terms of current. And then I did some time where I was borrowed to the system test section on the overhead line, did some testing on East Coast when that was being commissioned, and that sort of followed through for quite a long time, that type of work. And then to South Central, Sussex, as we call it now, became technical engineer in South Central for E&P, looked after conductor rail design, maintenance renewals, refurbishment of substations, TP huts. I moved into projects, so again went back to just before privatisation, went to Powertrack, and effectively was the lead engineer looking at commissioning, refurbing and commissioning all the sites like East Croydon, Holmful, Shepherd's Hill, and Purley Oaks. Which was a great thing. And again, with that, this is about managing risk, which is another reason it's on here. So sometimes we as Network Rail tend to think we want to push risk away. We want to push that to designers, contractors, stuff like that. And actually, that sometimes that's appropriate. There are times where I think we need to take more risk ourselves and make decisions ourselves and effectively be a bit more principal designery type ourselves. And what I mean by that is, I'll give you an example. So all of those sites have been out of service for 8-9 years. When it came to the contractors coming in to do the work, they all said, we need to replace all the lot. All the kit needs to be scrapped, all of it needs to be replaced, because they wouldn't accept the risk of something going wrong with that equipment. So I turned around and went, don't agree with you. There was one piece of kit at home at Shepherd's Hill that I agreed we needed to replace. The rest of it says, no, we will refurb it, we will clean it up, we will test it, we will commission it, put it into service. So myself, as project engineer, DPE in modern language, I guess, agreed that we would take that risk because it was so much cheaper than replacing all of that equipment. 30 years later, that kit's still there. Right? So actually the right answer. But if it had blown up, I still believe it's the right answer to challenge and for Network Rail to lead some of those design conversations. We're in a world where we don't have all the money we want. We have a world where everything costs a lot more than we think it does. And I think we need to somehow find a way of, yes, complying with CDM, yes, complying with how we work with our principal contractors and our designers, but actually being able to have those conversations and work. We're talking about true collaboration. That's sort of really, I think, what it is. I then, probably the first time I met Paul, I think, I then became area engineer in Wessex for E&P. So I had frontline teams working for me. I had cable and track, I had Conrail, I had distribution, substation work, all working in my organisation. So that was unlike track and signalling, which worked through a delivery unit. Effectively in Wessex, we had one delivery unit for E&P, and that was me. So, and there was a level where that worked because you couldn't go anywhere else. but also shown some weaknesses, because that's where we have to work as a system. We have to work together. And actually, the other theme of this talk is about not allowing silos to build up, that we actually break those silos down and talk between each others. And I've got some slides in later on that will show all of that. And that was also engineering leadership. It was a drawing office, design office, asset condition, renewal strategies, that type of work. So what do we need to do to get the outputs, i.e. the performance? What train service do we want to run? To actually say, to start putting to, at the time, the territory organisation, what do we need to do in terms of renewals? And then probably one of the longest periods of time, but actually the smallest on this diagram, but it doesn't matter. I became RAM, Route Asset Manager for E&P in Wessex. So that was roughly 10 years, where not only did I have the asset management strategy control, I had the business plan for the control period, submitting the proposals, getting them justified with the ORR, sponsorship of projects, obviously support for maintenance, because effectively all the support engineers were in my team, asset performance and sustainability and engineering leadership, vision, strategy. And I'll sum it up by saying, if anything went wrong, it was my fault. Which is hard, but it was absolutely the right thing. And in terms of accountability, there was no grey area about whose fault it was. It was mine. And the other great thing was, with the likes of Colm and Ronnie, in terms of signalling and track and the earthworks teams, we got to talk to break those silos down, to actually start talking about not just an E&P strategy, not just a signalling strategy, not just a track strategy, but trying to look at what we wanted, look at what the most important was, trying to balance and weigh up, what do we do? So, for example, all of us put money into Feltham resignaling, because that was the right thing to do, because Feltham signalling was falling to pieces, wide egg, all of those sorts of issues. And we needed to make sure that renewal was protected. Because, and I'll stop talking there, because I have got a slide which sort of sums up in a very clunky, crudy way, but sums up in a diagram all of what I'm trying to talk about systems and the dangers of silos. And then I became head of engineering for the whole of Southern Region for E&P. So that was when effectively we started to take more accountability from the centre, from the tech authority, to build up our ability to be masters of our own destiny. So one of the things that I really don't like is when we sometimes tend to be a bit like victims. To me, I want to go out and grab it. I want to be able to drive that strategy. I want to be able to, I'm not saying, oh, it's the tech authority, I've done this. Put something else to them. Change it. Fight it. And, you know, we've had a number of successes in Southern by taking that strategy, about quite often not accepting the first answer, but knowing what the benefits of what we're trying to do, like the Safer, Smarter Isolation Programme, which I have got a few slides later. The whole benefit of all of that could have all gone just by some negativity and some people saying we could never do it, and it was non-compliant and everything else. But we managed to achieve that. So that's sort of, I guess the context, what we've got here in Southern is, in Southern, we've got one of the highest percentage of electrified network of any region. So we're already 84% third rail electrified. And I'll talk later about a little bit about our strategy for that going forward. But I think the key thing, which sometimes doesn't come across so much, is we are 100% an electric railway. And what I mean by that is west of England, for example, between Romsey and Eastleigh, and between Salisbury and Redbridge, we've got electric signalling. So if there's no power supply, it doesn't work. So although we're not electrified, we have 100%. Even the March to Fawley branch has got power to make Marchwood signal box operate. And of course, on Southern, we've got, and Wessex is so lucky because it's unique, it has the overseas division. Which of course is electrified. And this is where, apologies for the slight clunky thing, but this is trying to talk about that building up that system. So we've got a train, call it a class 450. Bit of track. And then I ran out of ability to draw. So I thought I'd just put some blobs in this instead. So we've got track, got signalling, got electrification if it's electrified. We've got buildings and civils. We've got line side and drainage. So we're starting to build up that picture of that whole system. Foundations of all that is all on electric supply, because as I've said, we need to have an electric supply to keep the signalling, the comms, the telecoms, the data systems working. And the other part we need on there is operations and maintenance, because they're the groups and peoples that need to make it work. And that is effectively the system. And if the system's all there, and it's all operational. Which is what our business is. Funny steel boxes on steel wheels actually moving at the end of the day. And then, of course, when that doesn't happen, you have a failure, like we've got a failure where the signal power supply fails. I could have drawn some nice things with things like that, but I thought I'd show a trap buckle or something like that. We're bearing in mind the audience we had in the room to say that we then couldn't run the train, because that's the equivalent, effectively. So what I want to move on to now is sort of the future and our vision about what we want to do. And I think it's really important, and these are all the points that we're trying to drive the conversation. So it's not anyone else doing this. This is us in Southern that are actually driving all of this. So, and just remember, this is a vision. So I'm not saying there are any dates on it or where we're always going to get to all of this, but this is the vision about where we want to be. So we don't want to have any electrical incidents or accidents. So what are we doing about it? So we've got our safer, smarter isolation program. So instead of having to go out and fit short circuit straps on the track at night to do isolations, we've got fixed equipment that's operated by switches in a line side cabinet in a position of safety. So it removes the risk of the train versus person risk. It removes electrical risk. And actually, it removes people putting things in the wrong place risk, because you go to a box that's got numbers on the isolation form, and it makes it so much simple. So Southern's got this principle: keep it simple. So that's one of the things we're trying to do to drive. Where we do have straps, we will be putting down designated strapping points. So we've got some, for example, at Waterloo, where at the moment we need to retain some straps. We want to put a plate on the infrastructure that says exactly where it is, so people don't by mistake go to the wrong location. We want to improve the safety in train care depots. So in Southwestern Railways depots, we've been doing a load of work with walkways, guardboarding, trying to minimise those risks by having lots of conductor rails around the train care depots. Where we can, we want to remove floaters. So a conductor rail floater is normally a short length of conductor rail around points and crossings. Where we can, we want to get rid of them. And that's where, we've got, again, this is the vision. It's not saying we're going to get there in 5 years or whatever. There's lots of things that we need to have to help us do that. But we also want smarter isolation. So it's fitting a possession around an isolation rather than an isolation around a possession. Make it so much quicker, and so much smarter, and reduce so much risk. Even if it means we have to block slightly different locations, it can mean that we don't have to go out and fit short circuit straps. We don't have to operate hook switches. All of which is risk, and all of which takes time. So even sometimes where we've got an emergency work we need to do, where we've got NSCDs fitted, quite often taking a bigger area is actually quicker than what we'd have done in the past of operating sort of on a 4-track railway, 8 hook switches to minimise the isolation and then fit straps everywhere, operate hook switches, fitting straps. Now it's much quicker to take the whole electrical section because we can do that by switching switches in a box rather than having to go out, operate hook switches. And that's where it's about being smarter. It's trying to drive that, doing things differently to get all the benefits we can from the investment. So we don't want to have EMP failures. Electrification is the true digital railway, really. We've had it since 1915. It's on or it's off. 1 or 0. So when it's off, we can't run those funny steel boxes on steel wheels. So we need to try and manage our network. We design it so there's a level of resilience in it. We want to try and do all the things about get the interventions, the right place, the right time to try and mitigate the risk of failures. We want to use train-borne monitoring, a bit like PLPR, a bit like pattern recognition, which is PLPR, I guess, is not. You know what I mean? Using train-borne intelligent monitoring to look at conductor rail cables, infrared cameras on trains, on service trains, trying to get those impending doom alarms in the day rather than just relying on individual services. So we can do all sorts of stuff. We can have the longer term asset management plan, and we can get what I call the impending doom, because if we get impending doom alarms, we can sometimes get people out of time to correct that fault before it actually causes a big issue. So we in Southern, we want to be the third rail DC industry leader. That's not to say that there aren't other regions that have got DC or third rail, but we don't. This is where we want to grab the future ourselves. We don't want to wait for the tech authority to tell us what we can and can't do. We want to have our own strategy. We want to lead that conversation. And if, as long as I don't run out of time, we will just have a few look at those few things later on. And of course, in that, what we will then do, and which is already happening, is we then support the other regions that have got other bits of DC. So it's not as if we'll do Southern, put the shutters up. This is purely, remember I said, break the silos down. This isn't saying Southern's on its own, we're just going to do our own thing. This is helping lead everybody. So other regions have got NSCDs. Other regions are taking benefit of all the new technology that we've introduced in Southern, because it makes sense. Why do everyone have to duplicate? But conversely, why does it have to go through the centre? Because if it's done in Southern, if it's done in Wessex, if it's done wherever it is, there's focus, there's a want, there's a real commitment to actually drive that improvement. And I think it's so important to have that at all levels, not just engineering, but through the maintenance teams. Nothing better than to get people wanting that change and wanting to get that thing delivered. And so the Safer Smarter Isolation Programme, the challenge we had from a lot of the teams was not about not agreeing with it, it was not being able to roll it out quick enough. And that was a fantastic place to be, where you've got that change programme where actually the challenges are you can't roll it out quick enough for people, rather than having to sort of try and find a way of getting people to take what we're doing on board. And then the other exciting areas that we have a technical failure here. We've got bear with us. Or switch it on and switch it off. IT crowd advice worked very well in the past. Yeah, just bear with us a second. Can people still see that on Teams?
Yes, yeah, on Teams we can.
Seem to kill the monitor here in the in the meeting room.
Eventually. Press it in now.
Decarbonisation friendly.
Yes.
Just times out on carbon.
Kicking in again.
You went half an hour without praising the people of your watching.
Thanks, Phillips.
Flip the screen.
Get the menu up, don't you? The HDMI. See the home button. Table.
It's not the same thing.
I think it's the table
Was
one.
it tablet?
Yeah,
Hey.
thank you, Phillips.
So, can you see that?
Still got it
On
okay,
Teams.
Nigel, yeah. Yeah.
There's a red box around it, so I'm presuming everyone's okay.
Yeah, we can see that.
Moving into the future, talking about making our power system more efficient, decarbonisation.
Do to sort out this. Apologies, the screen's playing up again. Let me just try it. I'll try and select it again.
Okay. Right. I'll keep talking anyway, and then Paul will try and beat the screen, battle it into submission. So yeah, to decarbonisation. So we're talking about things like energy storage. We're talking about looking at DC battery storage where it makes sense. We're talking about peak lopping. We're talking about be that HVDC. We're looking at being able to feed solar power into our system. I've got some slides later, so I won't spoil the story completely, as long as the TV doesn't give up completely. And then, of course, we've got things like wanting to decarbonise by eradicating the diesels that we do have on our network, such as West of England and the line from Salisbury down to Eastleigh and to Redbridge. And there are others in the southern region as well. So again, bear with me while I do that. Fit for the future. So where we want to get to is we want to drive the conversation with industry. So there are times where, as an industry, if we want to upgrade the power supply system because we want to run more trains, it can take 5 years, it can take 6 years, especially if we need a new grid supply point. So someone rocking up and saying, we want to buy some new trains, or we've got these second-hand trains we just want to suddenly introduce into the network, doesn't really work for us. Historically, we've been funded to provide a timetable capability rather than a strategic capacity capability. Where we want to get this to is we want to lead that conversation. So instead of getting grumpy when someone comes in with new rolling stock or a new idea, we want to go, that line, say the line from Guildford down to Havant is 4 or 5, 12 cars an hour in each direction. As a strategic level of capacity, then as long as the timetable and with some power constraints about what type of trains they are, clearly, then timetable change becomes really easy. It's very clear to industry about what is the capability of the network. So it's moving again, it's trying to grab and drive that rather than wait for people to tell us what they want, because they never give us enough time to actually build that. And of course, you know, as the story about the infrastructure and the system, without power, we don't have the ability to run the trains, therefore the system fails, even if we have the best track in the world, even if we have the best signalling in the world. So embracing new innovative technology. So we are looking always at challenging ourselves with the pieces of kit we get. We're looking at solid state DC circuit breakers, for example. We're looking at you know, at all sorts of areas that we can get some benefits, efficiencies, whatever you want to call it, from in terms of driving that conversation. And of course, the other thing we want to do, which I have got a slide later on, is talking about new stroke infill type electrification in terms of carbonisation. And where would we all be without people? So we have a people strategy. We, in Southern, there was a time where, for example, the tech authority used to tell people new coming into this industry, DC's finished, DC will be gone in 2 or 3 years, don't bother working in Southern. It was always nonsense, but it did cause us a problem with people deciding not wanting to work in Southern. So we've now grabbed that, we've grabbed the grad scheme. Instead of saying you've not given us people, or you've not told people they live north of the Thames or they want to do OLE engineering, we are now involved in those conversations. We look at people in the eye, what do you want to do? Do you want to do OLE engineering? If you do, to be fair, Southern's not the right place for you. If you want to do DC, there will be at least 1, if not 2, if not more, careers of working on our DC third rail system. And then we want to help them to learn and to grow. So, for example, I've worked at the PWI is currently working creating a DC training package that I'm very interested in trying to get involved with, to try and so that we can help our own people, not just grads, not just other people that are coming in, but to actually try and get that right level of training that we can help our people through, to let them learn and grow and develop. Because I always call it about the conveyor belt of life. Okay, when you start off, you're at the beginning of the conveyor belt. When you get to someone like myself, you're nearly at the end and you're just about to fall off. And we need to have enough people coming on the beginning of the conveyor belt, because otherwise you end up with not enough people with enough experience, with enough competence to be able to run your part of the business. Doesn't matter whether it's E&P, doesn't matter if it's track, doesn't matter what it is. That's that same philosophy. So that basically is where what that plan does. So I then quickly just want to go through a couple of slides on the negative short circuit devices. So clearly, before we had NSEDs, people had to go out, they had to fit short circuit clamps. These are the picture of all the bits of kit you really had to take to site to be safe to do it. So we have to put short circuit straps or NSEDs on a section to stop the conductor rail, the risk of that conrail becoming live again. Because if that conrail did become live in like whatever reason, and people are working on it, working near it, then clearly that can go badly wrong and badly injure or kill people. So we need to protect to make sure that that can't happen. Not the easiest bit of kit to take to site, not always by access points or strapping points either. So, and this is where people haven't always followed the right process. If you follow the process exactly as it's written down, as people are trained to do, it's 100% safe. If you don't follow the process correctly, like you don't test before you put the short circuit bar down, you don't put the short circuit bar down, you just go and kneel in front of a live conductor rail offering up a short circuit, then very sadly, it goes badly wrong. And unfortunately, we have had people that have done that. With NSEDs, that eradicates all of that risk, because we basically take all that track-based work that we have to do and actually move it into a place of safety. So you're really right by an access point with normally that's got somewhere you can park your van as well. It's all operated through switches and indications back to the person operating the equipment, and all the equipment itself is fixed equipment in substations that can many hundreds, thousands of times actually carry out that short circuit capability. So it's moving, it's making it smarter. it's eradicating that risk. So it reduces driving, it reduces the train versus person risk, it reduces slip, strips and falls because people don't have to go out on the infrastructure, and it reduces the risk of people getting it wrong and being in contact with the third rail. And of course, one of the other benefits we get from this is it also makes that process quicker. So we do get a level of time benefit from being able to undertake that work of infrastructure in a quick way. Because if you've got a 4-track railway and you've got a set of NSEDs in a sub operated by a local control panel that's literally right by the access point, it literally takes 30 seconds. It would take a lot longer to fit the short circuit straps to all those other electrical sections. So that gives us a benefit, either in terms of the amount of work we can do, or actually giving us more time to do the work that we've got to do actually in that. So both of which makes it safer. So in Wessex, we are probably about 70% through the programme at the end of this control period, at the end of this year. There's a load more areas that are due to go live in terms of implementation shortly. Sussex and Kent are slightly further behind in terms of that implementation strategy, but the intention is at the end of CP7, all electrical sections will be protected by NSEDs, and the highest levels of operations of hook switches, they'll all be replaced with control track devices. That means the ECO, the electrical control operator, can actually operate them. So again, taking people away from risk, taking people away from going on the infrastructure, taking people away from operating a hook switch. And then with this one, the other key theme for this is effectively evolution. I'm not a fan of waiting for utopia. Okay, so as we started this journey, we had a standard negative short circuit device. As we progressed with that journey, we've now got busbar short circuit devices, which means that we only need to fit one device rather than 4 on a 2-track railway. It means we don't have to fit those at TP huts, and that can make it cheaper to fit to the more rural outer areas like Bournemouth, Weymouth, like actually the Portsmouth line, because it just fits in that possession strategy, being able to go to that busbar type technology. We've now actually got an integrated control track switch and short circuit device in one box. So when we go and fit a CTS now, we don't have to fit one device and then fit an NSED either side of it. It all comes as one integrated package, which makes it cheaper to install. And we've now got integrated circuit breakers and negative short circuit devices, which makes it much more efficient if we're doing a DC breaker renewal anyway, because we fit one bit of kit rather than 2. In E&P, generally the cost of the kit's about 20%, 18 to 20% of the cost of doing the work. The rest is installation. So although the kit might be slightly more expensive, the time it takes to install it is also much less. It becomes much cheaper. But the whole point with all of this is we didn't wait until we had the integrated device. We started, because if we'd waited, there'd always be something else. So consolidated control. Instead of local control panels, we are introducing what we call consolidated control, where one control panel can control up to 2, 3, 4, 5 sites. So we only have to send one person to that rather than those 3 or 4 people. Ultimately, we want to have remote secure, where on these lovely things, we'll be able to lock out the SCADA system and be able to lock the ECO will operate the NSED, and we'll be able to protect that with a phone to stop the control of the ECO being able to recharge. But we're not waiting for that. The very fact that we're 73% in Wessex, we've saved tens of thousands of straps being fitted on our infrastructure. And each of those straps we saved is potentially someone getting it wrong, putting themselves at risk. If we'd waited for utopia, we wouldn't have even started. And I guess the moral of the story here, I'm very, very much in favour of an incremental approach to improving safety. Because I think life tells us if we don't do that, you never get there. You never actually get to utopia because there's always something else around that. Oh, we'll just wait another little longer because we're doing this. And then you never do it. And you continue to operate whatever you did for the last 30, 40, 50 years. And I've probably got 5 minutes left, I think. So I will fly through these, Paul, before you kick me. So in terms of renewable traction power, the diagram shows at the moment our standard setup where we've got power generation. We use National Grid to distribute it to a grid substation or DNO, and then we've got our own line side high voltage distribution system. And we can decide at the moment, as we do, the energy we buy comes 100% from nuclear. So actually decarbonisation, we are already decarbonised because we buy 100% nuclear energy. But we don't want to stop there. The other options we've got is we can actually help fund through PPAs, power purchase agreements, wind turbines, solar farms, hydro, that feed through the national grid system to get to our grid system, to get to our system. So that's one of the areas we're looking at the moment, because that can provide cheaper energy. It doesn't necessarily answer the decarbonisation if we've got nuclear power, but it answers the question about getting it cheaper. And then the other one is we've looked at embedding solar generation, for example, actually in our own network and actually doing that ourselves rather than going through the national grid network. So we were, oh, sorry, this is energy storage. Just hold that thought for a minute. I won't tempt fate by going forward and back quickly. So the energy storage can actually help us be more energy efficient as well. It can sometimes just help recover regenerated energy that otherwise be wasted. It can actually help us to reduce the load on existing equipment, but allow a greater level of load on the network. So we've got a trial at Weymouth where at the moment the trains go down the hill into Weymouth, down Lincoln Bank, all regenerating away for quite a long time, but there's no train pulling energy in the other direction because it's the same train that goes back. So that energy is currently wasted. So by putting in some form of energy storage at Weymouth, we are hoping to recover that energy of the train going down the hill, so that when the train goes up the hill, we'll be able to provide that energy to the train rather than take it straight from the national grid. It's a proof of concept rather than that's the best place business case for Weymouth, but there are lots of other applications of that technology. Likewise, at London Road, Guildford, there was a scheme South Western Railway wanted to do, and it's gone a bit quiet, which is actually having a flywheel that if the voltage on the Conrail gets above about 830 volts, it'll actually power the flywheel, because that's what the regen energy will do from the train, and they're looking to help it power the station. So that's not for traction, but that's actually trying to provide other ways of recovering that energy that would otherwise be wasted. And they're both really proof of concept rather than being the final story. Again, if you never start, if you wait for utopia, you never get there. And likewise, Aldershot, we were the first country, we were the first organisation to have solar actually feeding the traction system in the world. Albeit in a very small scale. So if you ever go to Aldershot, there are a few very small number of solar panels by just on the west end of the station. It's not very big capacity, but it proved again the concept about how we can connect solar into our system. We were then going to do another bigger installation at Selmeston, which was in the order of 3 to 6 megawatts, which is much bigger. Unfortunately, we got into a problem with the way that we could contractually contract with the organisation that wanted to provide us with this power. And it wasn't the concept, it wasn't really the engineering that stopped it in the end, but it was the rest of the commercial, the procurement, and government sometimes not wanting to put money up front for a scheme that's got a payback period of 20 to 25 years. Because with a solar power station, you don't get it back in a year. It takes a long time to recover the cost for it. And then decarbonisation, which I will do in the next 2 or 3 minutes, because this is the other really exciting bit that we're trying to do. Because everyone always tells us that the ORR won't allow us to have new third rail electrification. So looking at decarbonisation, looking at things like the West of England line, looking at the lines around Redbridge to Salisbury, looking at things like Uckfield. We're looking at, one of the options we're looking at is third rail. We also look at 25 kV, because if 25 kV overhead was cheaper, why would I even think about challenging ORR and go to DC? I think you're getting the hint that actually OLE is a lot more expensive. Then we've got batteries. So battery technology is moving apace. There are things we can do with batteries we couldn't do a few years ago. Again, it depends on the length of train, how you get the energy into the battery. It depends on how far that train's got to go on battery. And it's quite a three-dimensional thing about when it becomes effective and it doesn't become effective. And hydrogen, electrification battery hybrid, and then potentially even a tribrid, if that's a word, electrification battery and diesel. Because West of England is an interesting case. There are long distances. Battery doesn't always really work. The amount of power you've got to get in the train, if it's pure battery, doesn't always work in terms of cost. So actually, at hydrogen, you need to take a lot of space up on the train because it's a very low density, energy density medium. So, for example, in a 4-car, if we're talking Uckfield, one of the carriages in a 4-car, 3 in a 12-car would have to be full of hydrogen, which negates the whole point about having a long train full of people, because no one's paying for that hydrogen to be moved around. It's cost. So the answer is a mix of all of those things. And this is where I think it's wrong, where people just look at one example and say, the answer's battery, what's the question? Or the answer's overhead line, what's the question? Or hydrogen, whatever it is. You've got to look at the application. Uckfield line, for example, they want to run 12-car trains. To get the amount of energy into a battery to go 40 miles to Uckfield and back again, you've got to have an awful amount of energy to get in that battery for it to be able to do that journey. If it was a 2 or 3 car, it's much easier because you've got much lower levels of energy you've got to get into the train. Viva Rail, for example, will talk about their rapid charging system that's got a bank of batteries sitting line side that rapidly discharges into the train. That's fine if it's a 2 or a 3 car. If it's a 12 car, you need an awful lot more capacity of that type of equipment, which means it becomes a lot more, it needs more space, it is much more expensive. So we've been talking with the ORR about the challenges about further DC electrification. There's been lots of work with the RSSB as well about 21st century DC electrification. So one of the actual absolutes would be, we've got to have the safer, smarter isolations. We've got to think about how we plan and operate the network so we don't put people at risk. We'd have to have NFCDs, probably remote secure, and in terms of how we segment that line, it will be by design. We design the isolations in at that time. And then for protecting passengers, what we've talked about with the ORR is 2 options. They are worried about station areas. They're worried about station areas because people that have had too many beers or other alcoholic refreshments are available tend to do silly things at stations. So they might jump down the track and try and cross the platform, and it goes badly wrong when people trip and fall over the conrail. Or they may use the level crossing if there's one by a station, then use that to just go for a walk down the track for some random reason. So one of the things that we've looked at is saying, well, like any CSM type argument, how do you look at your risk? look at how you can mitigate some of those risks. So we are looking at ways that we can sensibly, cheaply mitigate some of those risks without going to a complete system where we have to switch every piece of conductor rail on the system all the time. So we're developing at the moment a trial for a very simple platform switching area type technology, which would be when there's no train in section would be de-energized. When a train comes in, it would energize that section. So although it wouldn't be protected, or it wouldn't be dead, the conductor rail would be switched off. So if someone did fall over and there wasn't a train coming, it would actually save that particular person. So we're looking at that because we want to give the RR a hook to say we are doing a safety justification argument. We look at the costs of OLE. Why aren't we for example, why wouldn't we do Uckfield at 25 kV? So we've got costs for how much it would cost to do DC, how much it would cost to do 25 kV. And actually we're looking to put an argument together to say the cost of 25 kV are grossly disproportionate for the benefits that it provides. So all of that's in the safety justification report about why we would propose to look at DC. Putting this on top of it shows how under a CSM, common safety method type argument, how we're looking at risk, how we're managing that risk, and how we're showing we're not just going to roll out what we've always done before, but how we want to address that risk, how potentially we can do that. So we can do it by platform switching. We could actually have a small traction basher on the train, because that's the other way of having a de-energized conductor rail in a station, that normally the train's got a small battery, but just got enough power to get into the station and then pull away from the station back onto the conductor rail. An industry solution. And that's where, again, we want to lead that conversation about that industry solution, about this technology. No one else will do it if we don't. If it doesn't have a safety justification, we wouldn't do it. If it doesn't have a business case, we wouldn't do it. But where it's got a business case, where we can make a safety justification for it, why would we not try and drive the conversation about what we can do to actually provide a third electrified system with all those safeguards for staff, for passengers, built in from day one. And you'll be pleased to know that's it, really. So sorry for a little bit overrun. We did have some technical issues. Yeah. So the real summary for me is that we will continue to develop and enhance our third rail system. I think the key thing for me, and what I always say to people, is it's an exciting place to be. We've got all sorts of new technologies coming. We've got all sorts of what we want to do, what we want to change. It's not something where you walk in there going, oh, it's always the same. It's been like this for 50 years. We'll always do the same thing. And because of that, it's a really exciting place to work with all the innovation, that increment, because we do things in an incremental way. All of that has been, for me, for example, it's been fantastic to be leading that, being part of that, seeing that real change we've taken from scrapping to having NSCDs, and then going through to things like the remote secure, which we've started having the conversations with safety regulators and the tech authority for. And it's not easy, but having that commitment, that enthusiasm, that drive is the thing that makes that difference. So with that, you'll be pleased to know that's it from me. Any questions?
Yeah, absolutely. Open the floor to questions. We've got a couple already appearing in the chat from our president in exile. But before going to those, any questions in the room?
Pretty much asked it at the end there. Actually, we're talking about the attitude of the ORR, future infill DC. But are you optimistic, having got that solution, which was very interesting to see as a possibility to bring them on side a little bit? The vibes I get is the ORR are very much set against any further infill electrification, and they look at simple like accident figures and fatalities, both amongst the workforce and public as well, that to try and persuade them to actually accept that. Have you had any feedback from the ORR to try and encourage you to think that might be a possible?
So yes, we have. Is the answer. So this has been I spent quite a bit of time taking the RR on the journey with us. And we're not there yet, I have to say. But the very fact that we are where we have moved a significant distance. So they're not saying no anymore. They like the way that we're addressing risk for staff, because we would, if we did upfield, we would integrate the isolation of the strategy into the overall design, so that we can absolutely make sure there are no residual hazards when it comes to isolations. We absolutely want to have either consolidated control, so you've got one person to mail what isolation. And then we want to look at things like this, the platform switching or small traction battery on the train to address the risk in station areas that are higher risk. And that's not the only thing we do. Obviously, the rest of the CSM argument is looking at fencing, looking at other hotspots in terms of, you know, where that line goes and how we can mitigate other risk and trespass. The ORR have not said yes. I've had several meetings with them, and they are encouraged by our thinking. It might still end up being you can't do it. But I think once we've got the safety justification report, we've got the 21st century work that the RSSB that we helped feed into did. I think it's starting to drive that compelling case for having a conversation about showing what we've done to change how we address risk to staff and passengers, and having a contact system. It doesn't matter whether it's 25 kV or whether it's third rail. The very fact you've got a contact system means you've got an exposed conductor. Yes, OLE, it's up in the air, and third rail, it's down on the ground, but it's still an exposed conductor. And therefore, we have to, even OLE, we have to address the risks that the ORR are concerned on about how we design 25 kV clearances and station clearances and all of that good type of thing. So I'm encouraged by the feedback we've had, albeit it's not yes. And I think until we were hoping to have driven the upfield line to a conclusion. Is there the money to do it, or isn't there? If it hadn't been for COVID and the question mark over recovery of number of people travelling in the southeast, and the money that's gone to other parts of the country rather than the south, I think we would have got upfield. Upfield's almost got a positive business case on its own, irrespective of anything else. It's a very, very strong business case. Because we do away with a diesel fleet, the TOCs costs are much less. It's like BR days, more effective use of rolling stock. Doesn't mean you need as many diesel units as you've got. You'll need electric units for its uniform training, so it reduces cost of training for drivers and guards. You need less trains because electric trains need less maintenance than diesel ones. And the story goes on. So the industry business case for upfield and lots of other infields is quite strong. Fortunately, when we get to the west of England, where it's not 10 and 12 car we're talking about, it gets a bit more of a challenge for the business case for an electrification option. And then we're looking at hybrids of some form. Can we get a battery option that's affordable, that's achievable, sensible? Because whilst an electric train can cut the journey time from Exeter to London on the west of England by about 25 minutes, if you've got to stop 10 minutes at every station or a few stations to recharge, you lose that benefit. And it's about having that integrated package of what we do, which is why I put that little blob on the side of the screen that talked about potentially accepting there's some lines that having a level of diesel might not be the wrong answer. And I think that's where we need to test all of this, is not to get too stuck in mantras about it, but actually go, because no one's going to thank us for adding cost to our industry. Because if we add cost to our industry, then the industry might not pay as people as smart as it.
To keep on side of our reception, Well, I think we'll just take one more question. So, as you priority to someone in the room.
I'd be interested in your views about diesel traction for the future with for freight traffic and for our own ballast train engineering trains. When you consider the third rail systems, you are this part of the country predominantly passenger services. You have got a bit of freight. Most of the freight that you do come onto it is diesel hauled and it's heavy stuff, like from Basingstoke into Southampton. So very heavy stuff. That has to be replaced. We want to get rid of diesels, fine. It's got to be replaced. I see your point about extending your third rail electrification and not change it to something else. There is little point in changing it. You might as well be consistent and carry on with the third rail. Everything is then compatible on the whole system. I can see all that. There's no point in you doing trying to think about overhead line electrification for a small portion. I can't really see that. I can see things like with the long haul of freight trains, say a West Coast Main Line, which I'm used to. We've got electric locomotives for that, so they can carry on for the future. A lot of the long haulers will sit to that. But coming on to the southern is going to be, I can see in the future, a difficulty because you will. Where is the traction capability with the heavy freight trains that we've currently got into the future? Where do you see that coming from?
So, we've had electric freight for some time. We've had Class 73 EDs that have hauled not as long or heavy freights around Southern. We've had Channel Tunnel freight where we specifically upgraded the power supply system to be able to take a number of Class 92 trains using the Conrail as a power supply. So the answer to your question is it's one of the areas we're looking at in terms of the strategy for West of England and for the Redbridge up to Salisbury line. Do we go 25 kV? Don't we go 25 kV? What would it cost to upgrade the DC network to be able to take a Class 92 for those two trains an hour? It's all doable.
Yeah.
Any option engineering is doable. What I can't tell you at the moment is how much it costs or what the whole life cost or the better solution is. But the one thing I will say that we always have to be careful of is at the moment we can run the freights via Leverstock or we can run the freights by Winchester. If we just did, for example, Southampton to Basingstoke 25 kV on the main line, then we'd never get access overnight to do work. So any electrification, whether it's 25 kV or DC, has got to look at the strategy. How do we maintain the rate? It goes back to that first question really with the Class 31, doesn't it? How are we going to maintain our infrastructure if we never get access? It's already impossible between Reading and Basingstoke because there's very little access because that is a pinch point. And if we were to do 25 kV on that, there'll be track machines in the way of when people want to maintain the overhead. So the overhead will fall down eventually. So it's trying to come up with that integrated solution as to what is the best thing we do. How much is it going to cost? And is the money there? The answer may be, if the money's not there, it might be the Class 99 or whatever the heavy freight 25 kV and diesel loco is. That we accept at one point, maybe for the short term or medium term, that's what we use on those flows. Because there's probably other flows that might be cheaper in terms of electrification where you get more benefit in the short term. So it's all part of a study. As I said, we never rule out 25 kV. Upfield, it was pretty much ruled out because that is a short, it's sort of an infill, isn't it? And it doesn't have freight on it. But around the rest of the non-electrified in Wessex, it's very, very much about what happens to freight
and what does the freight industry believe is the right answer? What do they want to put money in terms of logos? Because the Class 66s and 70s won't go on forever. At what point do we get ready for or decide what, as an industry, what we're going to do? So that's very much an industry question that we're working on at the moment. Okay. We need
one comment on
if it's brief, we really need to move on.
I know
Well, it depends if you want to stay overnight.
For instance, the Great Western electrification has ended up with only a partial answer to all the questions that you're looking into at the moment. And you've got probably the worst of all worlds with that. We've got a partly electrified railway, but the other part of it is going to rely on diesels again. And there's no answer to that at the moment. That was really the point, that there has to be an integrated answer to this, doesn't there?
Yes. Thank you. Right. Apologies that we didn't get to ask some of the enlightened, informed questions on the chat, but we do need to keep on the right side of our reception team, our security team in this building. Happy to answer them by email if you want to. That's very kind of you. I'll try and transfer them. As two of them are from our president in exile, it would seem only fair that we do that. I'll see if I can pass those. I'm really delighted with this talk, and I hope everybody else is the same. And our guests that come along as well. It's a fantastic illustration of wisdom and considered engineering art. The cooperation between clients and contractors, be it between regulator and implementer, and is just key to what we do. And I suppose the other theme really is the importance that was illustrated about driving rather than waiting. A very simple message that it's not so easy to get, and just to keep in anything that you do. The one thing that I suppose that comes out of this that doesn't feel fully satisfied is I'm concerned we need to get you a mattress for the end of your conveyor, or we get you another conveyor, but we need to come up with a design for that. Yeah, maybe that's that. But thank you, Nigel, and if we can just take a moment to thank Nigel in the conventional way. And thank you for those on Teams. If you know all your way out, that's